Hi, my name is Shweta Gumpina, and I'm here to demonstrate my first project of CS441, which is on MapReduce. This is a repository containing the code as well as the documentation of all the requirements and the technical design. This would require SVT, Hadoop version 3, and Java 11 installed in on the machine. These are the different steps to run the project, which are clearly um, added here. And the requirements of this project was to create a program for parallel distributed processing of large graphs and display the distribution of nodes and edges based on their similarities computed using the specified formula. And at the end, we have to calculate the goodness estimate similar to precision and recall ratios. This is a technical design that I've incorporated and I've documented it in detail. Moving on to IntelliJ, this is my project structure in SRC main class. This is where I've described all the jobs, the different jobs. Yeah, and I've set up the configurations. This is basically the three inputs, which is the original graph input, the perturb graph input, the YAML file which has the changes, and the last one is the output directory where we want our output to be stored. Now, using SBT clean compile assembly, I will generate the jar file, which we will then deploy on AWS. Just, yeah, using SBT clean compile assembly. So the jar is now successfully created at netmodel Let's now deploy this on AWS. I have to upload this jar in S3. So in S3, I've created a bucket called 441 assignment one. And then I have a folder called input, which has the original graph.ng's file, perturb graph.ng's file, and the YAML file. So I have another folder called jar. This is where I'll upload the jar file that I just created. Netmodels.jar and upload. It was about 97 MB, so it would take some time to upload. In the meantime, I can run this program locally using the configurations that I just showed. And let's see, I have my Hadoop running in the background. Let's see the output. My last job, that is algorithm performance job, has completed successfully, and the outputs come to resources.output, and the final results are stored in results.txt, which basically has the values of accuracy and precision. These are the outputs of the intermediate MapReduce jobs. Moving back to AWS, the jar file has been successfully uploaded. Now, I can go move on to EMR to create the cluster. So I'll create a new cluster. I'll name it 441 net game sim. I'll choose Hadoop because my project uses Hadoop. And I'll choose M4 large. And I would create a step. This would be graph comparison, and I have to give the path of my jar file and the arguments. The first argument is this. My first argument is the original graph NGS file. I'll be giving URLs. The second argument is the perturbed graph NGS file. The third argument is the YAML file. And the fourth argument would be the output folder directory. I'll terminate the cluster if the step fails and save step. Then I would have to choose a service role, my instant profile, and create the cluster. The cluster has started. It would take some time to get it up and running. So to access the URLs publicly, I have created a policy and added it to my bucket so that these URLs can be accessed by my cluster. Okay, the cluster is now running. Yeah, it's gone to the waiting stage. Let's see the step. It's completed. Now, if I go to my S3, refresh it, and go to the output, I see the final results.txt, which has my final results. If I open it, I see that the accuracy, BTLR, and the precision have been logged, which is similar to what we got when we ran it locally. And coming back to the intermediate file, so the first file that gets created is the nodes representation.txt. This is the preprocessed file which stores the node information of the original and perturbed graph. And similarly, this is the edges representation, which stores the edge information of the original and perturbed graph. The next thing is function one, which calculates the node sim score. So this has a similarity scores for all the nodes. Then similarly, for the edges sim score, both of these are pretty much the same thing. So I've suffixed it with function one. Function two calculates the likelihood. So if I open the result of this, so this tells us what are the edges that have been added, modified, removed, as well as unchanged, also the nodes. And the last one is a performance MapReduce job, which calculates the ATL, CTL, DTL, WTL. And in the end, it's the results.txt, which which show us the results. This is about it. I can go ahead and terminate my cluster. Yeah, thank you.